Perfect. So minus 6x plus 2 and plus 4. Combine like terms, 9x squared minus 12x plus 7. Is this what we needed? Is that clear?
That's just stuff with G, right? Yes, for hard one.
Okay. Do we need to do the other one? You want to do the other one, or
Please.
okay?
That's the one that I get.
So g comp f of x. This is g of f of x, which is g of x squared minus 2x plus 4. And g says 3 times whatever minus 1. Exactly. Very good. Awesome. Great job. So this is 3 times x squared minus 2x plus 4 minus 1. So 3x squared minus 6x plus 3 times 4 is 12 minus 1 plus 11. Good. Anything else? Anything else? I guess you won't let me start chapter 4 today. I see that. So let's do other things. Or I can start chapter 4. Chapter 4 will not be on the test on Thursday, of course. We only have about 6 lectures in which I have to finish the material. Because we have one more test, and I will review for an entire session before the test, so 2 of them are gone. And I do not want to present new material after Thanksgiving. I just want to review with you for the final exam. So we're basically down to 6 minus this one, so 5 lectures in which I have to present chapter 4 and 4 more sections afterwards. So 5 sections in chapter 4 and 4 more sections after that for test 3. Okay, but since,
In 5 classes?
I'm sorry?
You said in 5 classes?
Yes, we have to look at 9 sections in 5 classes.
And there's a test, right?
And there will be the test, yeah. I mean,
Well,
or we
more
can,
tests, right?
or we
There's
can,
the test Thursday, and then there's the final, or is another test?
there is another test. There is another test, test 3.
In 5 classes.
After 5 classes, yes. We can make it after 6 classes, but then we'll review less for the final exam. And I would like not to do that. Yes, babe?
Do you know what day our final is?
Yes, it's on the syllabus. If you have the syllabus, or I can look it up. Okay, we're stalling, and I don't like that. And it's also in the calendar. I put it in the calendar as well. So if you go to the calendar, to your class.
Can we do like number 2, but if the radical is in the denominator, find the divisor?
Yeah, it's the same thing except not 0. Yes. So if we go to the next month, and next month, the final is on Tuesday the 11th. Now, if you need to take the final early, if anyone needs to take the final early, it's fine. Just let me know. Okay, which problem are we looking at?
I just want to do one that's like number 2, like
Yes.
the one that has the radical
Okay.
in the denominator.
So for x minus 1, the square root of x plus 4. We're asked to find the domain of this function. What condition do we have to write and solve in order to find the domain of this function? I have to write something and solve it. Greater than 0. I also have to state the restriction that has to be positive, but in this case, it cannot equal 0 because it's in the denominator. So then x greater than -4, so then domain is -4 to infinity with a parenthesis.
So if there's a square root in the denominator.
Whatever I have in the denominator cannot be 0.
Yeah, I mean in the numerator.
If it's in the numerator, it can be anything under the square root that is greater than or equal to 0.
So
But
that's
if the
only
quantity is,
time-
say-
that's
say-
the only time that creates a 0, is if the
Yes,
square root's in the
right,
denominator.
because the denominator can never be 0. We know that 0 in the denominator creates an undefined situation. Yes? Yes? Good. Anything else? Anything else? Is there anything else?
Is the one about like outer inner, is that always just like was under the radical?
It depends. It's the function that you have to apply first. It doesn't have to be under a radical. It can be just any combination. I can have, let's say, f of x, which is 1 divided by the square root of x plus 1. So there is more than one correct answer. What will you say the inner would be? It's the function that you evaluate first. There is more than one correct answer, so we can choose more than one possibility for the inner. But what would you evaluate first? Right. What will you evaluate second after you're done and you get one number here? 1 over x. Once you get a number for the radical, you will plug it in the function 1 over x. Very good. Anything else? Anything else?
Is it definitely going to be synthetic division on the test?
Division will be on the both types. You have to review both types. Yes. Yes. Long division, synthetic division. Yes.
Can we do a long division?
Sure. Okay. Any particular problem for long division? You want me to choose one or? Okay. So let's say negative x to the fourth plus 2x squared minus 3x plus 7. And we want to divide by x plus 2. They are in descending order. There is a missing term. The missing term has degree 3, and it's missing. So I have to leave some room there. And the first question would be, x times what is negative x to the fourth? We do not lie at the top. You know what I mean. It's not about lying, but I'm just reminding you that at the top we have to write the exact.
3.
Say it again.
Doesn't make 3 times, right?
Negative x to the third.
Negative x to the third. So negative x to the third. Do I have something? Stephen, am I writing something?
No, my glasses are bad, so I couldn't see if that was a 2 or a 3, and then I could
So sorry. So negative x cubed times x is negative x to the fourth, but I have to change the sign. Negative
I
x,
always have to change the sign now.
okay,
Sometimes I do it and I don't have to.
okay, not possible. So if I divide 2592 by 15, 1 goes into 20, 1 time. 1 times 15, I write 15 and I write 40?
No.
No, I have to subtract and I write 10. For that reason, I always have to do it. I always have to write the opposite sign, mandatory at all times. Very good. So negative x cubed times x is negative x to the fourth, subtract. Negative x cubed times 2 will be negative 2x cubed, subtract. I have to write the opposite. I subtract the negative quantity, which is positive now. I bring down 2x cubed and plus 2x squared. Now at the top we are true. We write the true signs and everything. So what do I have to write?
2x squared
And the sign.
plus
Very good, awesome. 2x squared. 2x squared times x is positive 2x cubed we have to write the opposite. 2x squared times 2 is 4x squared. We have to change because we subtract. These two go away. Perform the operations I see. Negative 2x squared minus 3x. Now, let me stop for a moment because I was just thinking to say this. If you don't change the sign, then in your mind you have to subtract. But if you don't see the subtraction, will you do the subtraction? In other words, for example, let's say I write positive here. Because 2x squared times positive 2 is positive 4x squared. But will you perform this operation and write negative 2, or will you add 2 to 4 and you get 6? So that's why I don't write positive, but I subtract. I write the exact quantity with the exact sign that I need to use to get the next step. So we can go back and see, there are different methods. This is the method I recommend. But again, this was in 3.3, because now I'm curious. See what they do. So they put 6x to the fourth and 6x to the fourth, but then they put a negative sign in a little circle, and they get 0. So 6x to the fourth and 6x to the fourth is 0. But you have to take into account the negative. That's fine. Then here, it's 5x cubed minus 4x cubed. It should have been x cubed. But they changed the sign and they put a little circle, a little positive sign in a circle. So now you're not performing what you see. You have to perform 5x cubed plus 4x cubed to get 9, not this sign. If that is better for you or it's easier for any of you, that's fine. I'm fine with that. But instead of doing that and going back on top of it and correcting it, I write what I should have in there so I can perform the operations I see and not the opposite ones. Is that better? So, but again, it's a good method. I never use that because I prefer to teach my students to write the correct sign and correct term and then perform what they see. Because if I write plus, then I have to come back with a negative in here on top of it. Would you get the same answer? Of course. Is it acceptable? Yes. Okay. So x times what is negative 2x squared?
Negative 2x.
Very good. Negative 2x times x is negative 2x squared, positive 2x squared. Negative 2x times 2 is negative 4x, positive 4x. What do I write next?
Negative.
These two go away. I write positive x and plus 7. Final question, x times what is x?
1.
And I write positive 1, positive x, negative x, positive 2, negative 2. So I box in 5. Then I write the answer of negative x to the fourth plus 2x squared minus 3x plus 7 over x plus 2. I write it as the quotient as negative x to the third plus 2x squared minus 2x plus 1. And then plus 5 over x plus 2. So now if you have any doubts, which is fine, it's good to have doubts. I'm not asking you to doubt yourself. I'm just saying it's good if you say, okay, let me check this, just to make sure. So if you multiply x plus 2 by this polynomial, and you add 5 to the answer, you will definitely get this quantity. Guaranteed. You want us to do that?
No, I get it. It's okay.
Is it better?
Yeah, it's good.
So I'm fine with the method from the book, and I'm fine with this method. It's up to you. Whatever works for you. Is this better? Is the long division better? Okay. Is anything else that you would like to go back to? Any other type of problem that you would say, let's go and do one more?
Let's do one more synthetic division.
Very good. Does this work with synthetic division? Does this division work with synthetic division?
Yes.
Good. So what goes in the box then?
-2.
Very good. Remember, we compare it to x minus a, and that's how we determine a. Okay? So it's -2. Now the leading coefficient is -1, but the next one is missing, and I have to write 0. The next one is 2, the next one is -3, and the last one is 7. Synthetic division requires us to copy the leading coefficient always. We're not, that's not where the algorithm starts. The algorithm starts after we copy the first coefficient or the leading coefficient. Okay, so -2 times -1, I get the correct answer to be 2. I perform what I see, and I get 2. -2 times 2 is -4. I perform what I see, not what I should see, and this is -2. -2 times -2 is 4. And -3 plus 4 is 1. And -2 times 1 is -2, so what I box in must be 5. Since we divided degree 4 by degree 1, this must correspond to degree 3. There is no question. It has 4 terms, so it has to start with degree 3. And that's it. -x cubed plus 2x squared minus 2x plus 1 plus the remainder 5 over x plus 2. Is this better? Anything else about anything else that we talked? Anything? Anything? Yes, Journey?
For long division.
Yes.
Do you flip it? Do you change the sign every time?
For the long division?
Besides, like the first one, you flip the sign.
Okay,
But
so
do you
when
it
I
again?
divide 2592 by 15,
Yeah.
1 times 15 is -15, so I have 0. I bring down the next in line.
Yeah.
So now I'm asking myself, 15 goes into 109 how many times? 2, 4, 6, right?
Yeah.
Is it 6 or 7? It's
Or
7.
60.
7. 7 times 5 is 15, and I carry 1. And 5 and I carry 3, so it's 10. Do I add or I subtract? Do I add and get 214?
Sorry, every time. Yeah.
Right. So I meant here. I always have to subtract.
Okay.
I always have to change the signs before I write under the like terms. I do it for the first, I do it till the last. Mandatory in all cases. Because I always have to subtract.
I just thought of it.
That's okay. So once I multiply, I get positive, but I can't write positive.
Yeah.
If I multiply and I get negative, I have to change the sign because when I subtract a negative quantity, it becomes positive. Now here, I don't have to do it because I already take care of the sign already here. So it's positive 2, so I write -2. That takes care of all of them in one step. But for the long division, I need to do it every time I find the quantity. The quantity at the top is no lie. So that is one problem here with this method. So you have to be careful because I don't even know what they did here. I'll tell you the truth. They've factored, I have no idea this. What are they showing here? Change signs of the polynomial being subtracted. So you have to say, it's, they show you that they change. So -5x plus 2x is -3x. But if you look carefully, this looks like -7x. Yes, I just wanted to say that the quantity that we get here, let me go back so it's easier to explain. So they do get the same correct answer here, but they started with -2x cubed here, but they all of a sudden they have positive 2x cubed, which is fine as long as because they determined this quantity correctly. But just be careful. If you use that method, it's acceptable. It's a good. Yes, please, Stephen.
Oh, no, I'll wait for you to finish.
I said it again.
I'll wait for you to finish.
No, I was done.
For the synthetic division, just want to Does any coefficient of the denominator have to be 1?
When we use synthetic division?
Yes.
Yes, so let me show you, it's a very good question. Let me show you what happens if, for example, let's say I have x to the third plus 2x minus 1 divided by 2x minus 2. What I have to do in this case, factor out 1/2, perform the division like this, and then distribute 1/2 to the answer. So I can use synthetic division if the leading coefficient is not 1. I cannot if the degree is other than 1. That I
Right.
cannot. But if the leading coefficient is other than 1, I can, but I have to factor it out by force. And if it's not factored when I have 1 here, then I'll have 1/2 here. And in the box, I will have 1/2 instead of 1.
Okay.
So I will perform the division, and then I will distribute to all terms in the quotient, 1/2, and including the last ratio.
Okay.
We didn't do an example like that. I didn't think there was one in the book, but if you find one, we can work on this problem if that's what you want. But I don't think, was there a problem like this?
Not that I'm aware of. This is a question I had.
Yeah. Yes, it's possible, but you have to factor it out. Yeah. And then you put it back in.
Right.
So whatever answer you get, so imagine that we get this answer here. And let's say I had a 1/2 in front. Then this would have been negative 1/2 x cubed plus 1/2 times 2, which is x squared, minus 1/2 times negative 2, which is negative x. And this one would be 1/2 and plus 5 over 2 and in parentheses x plus 2. It will get distributed back to all terms. Yes. We didn't look at an example like that. Is there anything else that we have like 4 minutes, 3 minutes. If there is anything else that you would like to look at. And please do not miss the test on Thursday.
Can you just tell me how
Yes.
I got FX? I mean, I understand the numbers, but it's like, I know
Oh, so the
which
six
is
root.
which.
Right. So here's how we're thinking about that. So if we have, let's say, the 6th root of x to the 7th plus 4, and this is a function, let's call it h of x, the inner will be the first expression I have to perform, which can be more than one correct answer. The outer will be the next expression I have to perform, which is the 6th root of x.
So FX is always the inner.
Oh, depending on how you want to call them. So I think they want us to present f comma g, not g comma f. If they want f comma g, g is the closest to x, g is the inner.
One paper matters, but
Yes.
saying it.
For me, it doesn't matter. Right. So f comma g of x, look, it's f of g of x. Which function we apply first? We apply g first. So g will be the inner. Which function we apply to this answer? F. So f will be the outer. Now if I want to call it g comma f, look at the definition. G of f of x. This is the inner. And this is the outer. That's how we determine f comma g or g comma f, right? We start from the inside. So we replace f of x first, and then we apply g to that. So always write the definition, and then you'll say, oh, okay, the inner must be g in this case, and the outer is f. Which one is the inner here? F is the inner, and then I apply g to that.
Reading is fundamental.
Right. Any questions? Is there anything else that you wanted to look at?
My brain is on overload.
I think we should be okay for this test. What do you think?
I hope